Here's an easy one to start. Do you think the Earth is flat, or do you think it's a globe? Now, you're probably thinking, well, everybody knows that, or possibly you're thinking something less polite. But remember, what we're interested in here is scientific answers. That means answers that are backed up by evidence. So, if you're thinking, well, obviously it's a globe, why? Why do you believe that? Well, again, that doesn't seem like too hard a question. People have flown up into space, looked out the window, taken pictures. You've seen the pictures. It all seems fairly convincing. And yet, in a 2019 survey in this country, when people were asked if they agreed that the Earth was flat, around 7% either agreed or at least were unsure. In the United States, in a 2022 survey, that figure was rather higher, and amongst people under the age of 40, more than a quarter either agreed that the Earth was flat or were unsure. So, what's going on here? Well, if you ask them, they say, well, how do we know that those pictures are real? We know that there's lots of fake news out there. Those pictures could just have been invented. We haven't been up into space ourselves, so we don't trust what people have to say about what they see up there. Now, in a sense, that's an admirable scientific attitude. The oldest science club in the world is the Royal Society, which was founded in London in 1660. And their motto, if you'll forgive my Latin, is nullius in verba, which means, in effect, that you shouldn't believe something just because someone tells you it's so. You should look at the evidence and decide for yourself whether the conclusions that others have drawn from it make any sense. And that skepticism has become the cornerstone of the scientific method. There's a problem, though. Even in 1660, it would have been a tall order for those people gathered together at the Royal Society to repeat all of the experiments they heard about for themselves. And today, of course, that idea is utterly ludicrous. There's just so much science out there, and a lot of it requires technology that most of us don't have access to. So, how can we square this circle? Well, we rely on the fact that there are a lot of scientists out there, and they're all bristling with skepticism. So, whenever a new result is reported, or a new scientific model is proposed, there will immediately be other scientists sniffing around, looking for the flaws. And the more important the claimed advance seems to be, the more eagerly they will swoop down, seeing if they can pick the work to pieces. And actually be quite confident that any fraud, or much more commonly, any honest mistake, will soon be uncovered. And that's how nullius in verba has to work in modern science. An example is cold fusion. In March of 1989, a couple of scientists at Southampton University claimed to have discovered nuclear fusion occurring at room temperature. Now, this is the process that powers the sun, and everyone had assumed that you needed those extreme conditions to make the process possible. Here it was, being achieved apparently under the mildest of conditions. It seemed like the world's energy crisis might have been solved. But those other scientists swooped. The experiments were repeated, and the same effects not detected. The original reports were scrutinized, and flaws in the methodology were picked up. And by the end of that year, the idea was essentially dead. In our case, the important point is that lots of people from different countries and with different loyalties have been up into space, and they've all reported the same thing. And that's where our confidence in the model of a globular Earth must come from. Of course, when those first astronauts went up, they didn't get a huge shock when they saw the shape of the planet. The idea of the Earth as being a globe had been around for a very long time and was accepted by most people. It dates back actually to Pythagoras around 500 years BCE. He proposed that the Earth might be a sphere. In his case, it was actually just because he thought spheres were a cool shape, and he thought, wouldn't it be great if the Earth was that shape? But it inspired other people to look for actual evidence. By the time Aristotle came along, around 150 years later, he was able to pull together results and conclusions from a whole bunch of scientists to make a pretty compelling case for a globular Earth. He figured out, for example, that during an eclipse of the moon, the shadow of the Earth is cast upon the moon's surface, and when they looked at the edge of that shadow, they saw that it was curved, consistent with the Earth being a sphere. They thought about the reason why particular stars appear at different heights in the sky, depending on how far north or south you are, and they realized that this too was consistent with us all living on the surface of a globe. And they looked at ships sailing away and disappearing over the horizon, and noticed that the hull of the ship would disappear first, and the masts above it last of all, which is exactly what you would expect if the surface of the Earth were curved. Now, none of these observations on its own demonstrates beyond reasonable doubt that the Earth is spherical. It's rather that taken together they provide a weight of evidence in support of the model. And this is typically how it is with science. There is rarely a single definitive experiment that establishes a theory, rather a gradual accumulation of supportive evidence and an absence of contradictory evidence, which gradually builds up confidence that a theory has validity. But science is always ready to cast the theory aside if that contradictory evidence emerges. In the case of the globular Earth, though, that has never happened. So we actually have lots of pieces of evidence to help us answer the how do you know question. But what about that other key question? Why? Why should the Earth be globular? Well, Aristotle did kind of try to answer that question. In those days, people thought that the Earth was at the center of the universe, and observing how heavy materials tend always to fall towards the ground, he interpreted this as a desire of such materials to move towards this cosmic center. The Earth itself is made of such heavy material, so this too will be drawn towards the center. And Aristotle reasoned, if this were true in all directions equally around the central point, then a sphere would be the natural shape that would result for the Earth itself. Now this theory sounds strange to modern ears. It's based on a dodgy assumption about the Earth being at the center of the universe, and it has this mystical idea of matter desiring to move towards a central point. Nevertheless, it has strong resonances with the modern theory of how the Earth formed. Today we think of an infant solar system in which the young sun is surrounded by a great cloud of dust and gas. And its gravity, an attractive force which exists between all particles of matter, which gradually draws some of this material to condense together and form, ultimately, the planets. Now this gravitational attraction operates equally in all directions, and so, echoing Aristotle, we realize that the natural consequence of this condensation process would indeed be a globular Earth.